Welcome to my YouTube channel again, and today I'm going to talk about the basic statistics of photolithography. So to start with, um, we're going to talk about the PR, which stands for photoresist. We place them on the silicon substrate and we expose them with the light. So there are two types of PR, which is positive PR and negative PR. So for the positive PR, if we expose the light on the positive PR, the structure will get weak and there will be some chain seasoning issues, and because the place where the light got exposed will disappear if we put it on the developer. So what is developer? Developer is a material that if we put a PR into it and if we shake them, for the positive PR, the place where the light got exposed will disappear, as I talked to you before. And after we put them on the developer, we go to the next step called etching. So for the residue, after we put it in the developer, there will be some residue remaining, PR residues. So we want to wash them away. So we use a method called etching. After etching, we want to remove all of the PRs. So we make a step called strip. So this is the basic for the photolithography on the positive PR. But on the other hand, for the negative PR, if we expose the light to the place, and for the negative PR, if the PR gets exposed by the light, the structure will get more stronger, calling will get more stronger, and the place where the light didn't get exposed will disappear, which is opposite from the positive PR. So as you can see here, we put a negative PR over the silicon substrate and we expose the light, and the place where the light got exposed remains here. And we use the same step. We use etching for removing the residue of PR, and after it, we want to remove all of the PR, so we use a step called stripping. So this is the basic lithography, and I'm going to now talk about the reticle, which is the same name as the photomask. So it is a very important part to put it on the wafer. We expose a light on the reticle, and there are some structures that we want to place them on the wafer die. So as you can see, this is a picture for the reticle, and yeah, we don't want any particles to get into the reticle, so we use a material called pellicle. I'm going to talk about it in the next class, so I just want you to know what kind of stuffs are there. Now, when we do a photolithography, it is very important to make it is very important to design the structure that we want to make on the wafer. So alignment is a very important issue. So to make a less misalignment, we use a structure called alignment key. It is just like a key that you enter to your room. When you enter to your room, you need a key to enter it. So we also use alignment key to prevent from misalignment. This is just a basic structure of it. And as I told you before, this is a structure called pellicle. We put it on the mask or on the reticle to prevent from any particles to enter to the mask. So if there are particles in the mask and we expose the light, then the wafer die wouldn't be the same as that we want to make. So it is a very important structure. So this is just a very basic structure of photolithography. So first of all, we clean the wafers, which is the most important part, because if there are a lot of particles on the wafers, it will be hard to make a product. And we deposit the barrier layer by using silicon dioxide substrate or any metals that we want to make, as you can see here. And then we coat with the photoresist, as I told you, calling PR. We can use negative PR or positive PR. And after we finish stripping, we have to bake them. When we use baking method here, we use a method called soft baking, which is under about 100 degrees. This is just to make the structure stronger, and after it we make align masks and expose the pattern on the wafer. And we developed the photoresist again, and we now bake them in a higher temperature, calling hard baking. This is to make the PR structure more stronger. And after it, we use etching and to remove the photoresist. This is just a basic structure of it. Now we have some wafer exposure systems, which is a very important part. There are three types of wafer expose system. First of all, we used contact printing. This method is usually used by the school or any facilities in university. For contact printing, we put the mask or the reticle just over the wafer. We contact the wafer and the mask, and we expose them with the light. There are some problems by doing this, and there are some pros and cons of it. So for the pros, it is cheap and the structure is very simple. However, some PR can be left on the wafer and making some issues. The next thing to prevent these negative issues, we used proximity printing by making some space between the wafer and the reticle, and we expose them with the light. It has a less damage than the contact printing because no more residues will be remain on the wafer. However, it has a poor image resolution because of the diffraction of the light. So nowadays we use the projection printing, which is making using an optical system. By the way, for the contact printing and proximity printing, we used a 1:1 size of the reticle and for the die. However, nowadays using a projection printing, we use a bigger reticle and we minimize them with the optical system to the wafer. We use a stepper and scanner for the projection printing, and the optical systems are very complicated, and because we use a lot of lenses, it is very expensive. So on the next class, I'm going to talk about the stepper and scanner for the projection printing.